Howdy everyone, Mr. Kazi here with another chemistry lesson, and this time we're going to be talking about electron configurations. Remember when I told you at the beginning of all this, the electrons were the most important thing about knowing the atom. Because electrons are what determines the chemical bonds. All the chemical reactions are determined by the electron. So the electron becomes very important. And we need to know about valence electrons and Lewis dot symbols as we move on. And the best way to understand that is through electron configurations. So if you follow along and learn this lesson, and hopefully you've already gone through the quantum numbers lesson. If you haven't, go back and do quantum numbers lesson. With that lesson and this lesson, you should be ready to do valence electrons and Lewis dot symbols. And when we're ready to do Lewis dot symbols, we're ready then to go into determining how things react. So let's get started. Electron configurations and orbital notations. First of all, let's look at the difference. Electron configurations deal with the arrangement of the electrons in the atom. So we're interested in how they're placed, and it's more of a numerical representation. If I had chlorine, let's say, with 17 electrons, then I would look at it and it would be placed like this. 1s2, 2s2, 2p6, 3s2, and 3p5. But its orbital notation is more interested in how the orbitals and electrons are arranged and focuses on the placement of the electron, not so much just that there are electrons. And we use arrows to help represent that, and it would look something like this. There's chlorine, and again you can go through and count that. There's 17 electrons, and there's 1s, there's 2s, there's 2p, 3s, and 3p. Now, in order to do electron configurations and orbital notations, you need to know some certain things. So let's go through what you need to know. And first, you need to know atomic numbers. And of course, the atomic numbers right there in red. You need to know that everything on the periodic table is a stable atom. So if you know the atomic number, you know how many electrons are in the atom. You need to know that the number of sublevels equals n. And if you've done quantum numbers lesson, you know that. So if n equals 2, there are 2 sublevels, S and P. N equals 2, there are 2 sublevels, S and P. If n equals 3, there are 3 sublevels, S, P, and D, and so on. And that was all covered in quantum numbers. You need to know there are only 2 electrons, maximum, in any orbital. So you put 2 electrons in and you move on to the next orbital. Positions. S has 1 position, P has 3 positions, D has 5 positions, and F has 7 positions. And of course, each position can hold 2 electrons. So 2 times 1 is 2, and 2 times 3 is 6, etc. You need to know the Aufbau principle. Electrons occupy the lowest energy level available. And Hund's rule, which tells us when filling the P, D, and F's, S's only have 1 orbital, so it really doesn't matter. 1 electron must be in each orbital before pairing. And so there's a p orbital, and we're going to put 1 in each one. Now we can pair. Don't forget that. Hund's rule. All right, let's understand energy levels and their orbitals. Energy level number 1 has 1 electron, 1 subshell, which is S, and S only has 1 orbital. There's the energy level. Energy level 2 has 2 subshells, S and P. So S has 1 orbital, and P has 3 orbitals. Now notice also that I'm putting below the orbitals, I'm also putting their m sub L, or the third quantum number value, to help reinforce that. Energy level number 3. I'll bet you know there are 3 sublevels. So that's S, P, and D. S has 1 orbital, P has 3 orbitals, and F has 5 orbitals. 4th energy level. And I'll bet you probably already figured this one out. S, P, D, and F. Let's look at our F's. Have 7 orbitals. And it's very important that we understand these. Since there aren't any sublevels beyond F, I'm not going to go through any of the other energy levels. But there are some other things we need to remember about the energy levels. First of all, beginning with energy level number 4, the orbitals begin to overlap. And before 3 is finished, 4 is going to start. And so you'll notice there, 4s2 is going to come before 3d10, and we begin to overlap. And the same thing, 5s2 is going to come before 4d. And then remember, we also have some complications with jumping electrons. When the d sublevel has 4 or 9 electrons, a 4s electron will jump into the last d orbital. So you'll notice there it is, 4s1, 3d5 instead of 4s2, 3d4. And then here with copper, we end up with 4s1, 3d10 instead of 4s2, 3d9. An electron jumps. All right. Now with all this information, we should be able to go through and write configurations, and we should be able to do orbital notations. So let's look at some configurations here. Hydrogen has 1 electron, so its energy level is going to be 1. That means it has 1 sublevel. That sublevel is going to be S, and S has 1 position, 1s1. Helium, 2 electrons, still the first energy level, still just 1 sublevel. That sublevel is S. It has 1 position, but it can hold 2 electrons. So there's helium's electron configuration. Lithium has 3 electrons. So now we've got to jump into the second energy level, because the first energy level can only have S. There can be no P. But in the second energy level, we can have 2 sublevels, which would be S and P. And you'll see it's 1s2, 2s2. Look at beryllium. Same kind of thing as with lithium. S and P, but the P still has no electrons. And there is the beryllium configuration. Let's distribute boron's electrons. N equals 2 still. And so we're going to have 2 sublevels. That would be S and P. Now the P has 1 electron. And we have 1s2, 2s2, and 2p1. And you can continue that on using something like the electron orbital diagram that I had in the beginning of this lesson. You can continue distributing the electrons one by one as you go through the sublevels. The electron level diagram, here's a picture of it that I was showing you earlier. And you can see there that it includes all of the energy levels up through 7p, and you get an idea how the electrons are distributed and how they overlap to help you practice. If you want a copy of this, shoot me an email, and I'll see if I can get a copy to you. All right, orbital notations. Dealing with the electron placement, let's look at this one. Hydrogen has 1 electron. N equals 1. Pretty much the same so far as the thinking involved in doing electron configurations, but now we need to look here and see that it has 1 position. Now we're talking about the positions and where those electrons are. And so here is hydrogen's orbital notation. There you go. Has 1 electron. That's it. Helium. Helium has 2 electrons, still the first energy level, and 1 position. And let's put those electrons in. There we go. There's helium. Let's do lithium. Lithium now has 2 energy levels, 2 sublevels in the second energy level, S and P. But P has no electrons yet, and we'll put our orbitals in. There's the first energy level and the second energy level. Now let's distribute the electrons. 1, 2, 3. Pretty cool. Beryllium has 4 electrons, and like lithium, 2 sublevels, S and P, in the second energy level. But the S still has no electrons. So put in our sublevels. And there's the orbital notation for beryllium. All right, now boron. Now the P has 1 electron, and there's boron. And we keep distributing them as we go through the electrons. The number one thing here is practice, 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 and be on the lookout for a video on just doing electron configuration, orbital notation, using the information from the quantum number lesson. All right, everyone. Don't forget, if you have any questions, shoot me an email to mrkazi@mrkazi.com, and check out mrkazi.com. I have PowerPoint videos and much, much more there to help you out. And subscribe to my YouTube channel. That way you get notification of any lesson that I have done. And you'll want to keep up with some of the lessons that are coming up because they're free.